So there are basically three types of problems you're going to see on this particular test coming up, Unit 7 Quadratics. The first kind of problem is where you put it in the calculator and look at it. The second kind of problem, you will identify key attributes, so you can really just look at the problem and figure out what they're asking. And the third kind requires a little bit of mathematical manipulation where you're converting from one form to another. None of these are hard, and most of the problems really just involve you looking at something, not so much doing any calculations. So it shouldn't be too difficult. The first thing I want to put up here, though, is to show you some of the basics that you'll be looking at. So if we look at a particular quadratic, there we go, there's a parabola, okay? There's several key attributes, in other words, identifying marks on this that you would get asked about. The first are the X-intercepts. That's where they cross the x-axis. Now, there's three options you have for a parabola and the x-intercepts. One, it doesn't cross it at all. Two, it just comes down, touches it, and goes up. And three, it does like this red line does. It crosses it twice because it goes, the vertex goes below it. Okay, so there's 0 x-intercepts, 1 x-intercept, and 2 x-intercepts. Those are the only three options with a parabola. Okay, so let me get rid of a couple of these first, because we're not going to talk about those right now. Let's talk about this one. Okay, so that's one. Then there's the x-intercept. The vertex and the axis of symmetry. The axis of symmetry is the line that goes through the vertex. Okay, so the axis of symmetry is the x value of the vertex. So if this vertex was at, say, 2, -2, the axis of symmetry would be x is equal to 2, because that's this line here crossing the x-axis. Okay, so there's four things: the 2 x-intercepts, the vertex right here, and then the axis of symmetry. That's the fourth one. And then the fifth one is right here, the y-intercept. In standard form, y is equal to ax squared plus bx plus c. The c value is the y-intercept. The c value is y-intercept when the whole thing is set equal to 0. Okay, and those are really the attributes. So, excuse me, if you're looking at an equation, let me just erase this whole thing here. Okay, so if you're looking at an equation, say, I'll just make one up. Y is equal to x squared plus 8x minus 4. Okay, you know that the y-intercept is -4. So it's at 1, 2, 3, 4. Okay, so what you don't know yet, and you also know because this x squared term is positive right here, that the parabola opens in the upward direction. If it were negative, it would open up in the downward direction like that. Okay, but this one opens in the upward direction, so you know that this parabola is either going to look something like this or something like this. We don't know whether it goes to the right or to the left yet, so we kind of have to figure some of this stuff out. But at a minimum, you know that the y-intercept is -4. If this were your equation, y is equal to x squared plus 8x, then you know that the x-intercept would be at the origin, at 0. Okay, so but does it go to the right or to the left? Well, because I know about quadratics, I know that if this is positive, it's going to be on this side. And if this were minus 8x, it would be on to the right. Okay, but what's the easiest way to do it? Put it in your calculator and look at it. Okay, now some of the problems they'll say, here's the graph. They'll give you a graph. In other words, let me erase this stuff here. They'll give you a graph, for example. They'll give you something like this. Oops, erase all of this. Okay. Now, they'll give you a parabola and it goes something like this. They'll say, which one of these equations matches this? Well, the first thing you should look for is that y-intercept right there. Say this is -4. Okay, so your equation has to end in -4. If it doesn't, cross it out. It also has to be, the x squared term has to be positive because this opens in the upward direction. If it were upside down like this, then that x squared term would be negative, okay? But it's not. That's not what I gave you. I gave you this one. So you know that it has to be a positive x squared term. A lot of times they will give you 2 positive and 2 negative. So you can eliminate 2 already. You know that the y-intercept, that last constant term, has to be -4. And that may give you the answer without even trying hard. But if they both say -4 and they're both positive, now you only have 2 to put in the calculator and compare it to what you're given. Okay, so it doesn't get any easier than that. You can put all 4 in and see which one it matches if you can't figure it out, or if they're all positive and they all say -4 at the end. Yeah, you'd have to put all 4 in. Okay, but if you know a few things about this, sometimes you can eliminate 2 without even thinking too hard, and then you just have to put 2 in the calculator and see which one matches it. That's really how you do that kind of problem. Also remember that the x-intercepts are also called roots, also called zeros, and they're also called solutions. They all mean the same thing, okay? It's where the parabola crosses the x-axis. Okay, so right there and right there. They're roots, zeros, x-intercepts, or solutions. And that's really the gist of working on these parabolas. It's how to do that. Knowing what they're called. So when they say roots in one problem, zeros in another, you're thinking, oh, they want something else. No, they don't. It's the same thing. Okay, so, and as I also showed you, there's only 3 options for a parabola on how many roots or zeros or solutions or x-intercepts it can have. Okay, that doesn't cross. So there's 0 roots. And it doesn't matter whether they're upside down or right side up. It's going to cross it or it's not. Okay, this crosses twice, so there's 2 there. And then this one just comes down and touches it, so there's 1 there. Okay. So those are the only 3 options as far as roots, zeros, and so forth. It's either 0, it doesn't cross it at all. 1, it just touches it. And 2, it crosses it twice because it goes above or below it. Sometimes you might be asked, where's the vertex? okay? The vertex is right here, okay? It is right there. So all you have to do is count 1, 2, 3, 4, 5 on the x value, 1, 2, 3, 4 on the y value. So the vertex would be at 5, -4. And what's the axis of symmetry? Axis of symmetry is just the line that goes, it's the vertical line that goes through the x-axis. It goes through the vertex. So it's the x value of the vertex. So what's the axis of symmetry? Axis of symmetry, x is equal to 5. It's right there. It's the x value of the vertex. It's that easy. Okay, don't make it hard. Just look at the information you're given. Sometimes you'll be given a graph, and all you have to do is count blocks. And that's how you calculate. That's how you figure out the axis of symmetry or the vertex. Sometimes you're not given a graph, and they ask you for the axis of symmetry. How do you figure it out? Well, the axis of symmetry minus b over 2a. Okay, you should remember that from previous videos. Remember a, b, c. A, because there's nothing in front of the x squared term, is 1. B is 6, and c is -2. You don't need c in this particular case, so it's minus b. So minus 6 over 2a. A is 1, so over 2 times 1, which is 2. So minus 6 over 2 is equal to -3. So the axis of symmetry in this case would be -3. And that's the x value of the vertex. If you want to know what the y value is, then you have to plug in this -3. You plug it in there to that x and there to that x to get the y value for the vertex. -3 squared is 9. 6 times -3 is -18. 9 minus 18 is -9 minus 2, -11. So the vertex would be at -3, -11. That's really how you do that. But your calculator can do that for you too. Or you can just graph this and look at it. It's probably the easiest way to do that. So remember, when it asks you, what are the zeros of this particular graph? Okay, sometimes they'll give you the equation. If they give you just a graph, then you just have to figure out where does it cross the x-axis. If they give you the equation with it, makes it easy. You put the equation in there, then graph it, and if you hover over those points right there, it'll tell you what the x-intercepts are, okay? So you're looking for the x value, not the whole, well, because the y value is 0. So this would be like 2, 0. This would be like 5, 0, something like that, okay? So remember, the x-intercepts are when y is equal to 0, and the y-intercept is when x is equal to 0. Now, a lot of students always forget about domain and range. You never hear it called range and domain. Teachers always say domain and range. Why? Because they always say x and y. You don't hear them say y and x. It's always x and y. Ordered pair, okay? Because they follow the same order every time, x then y. Ordered pair is the x value then the y value. Domain goes with x, range goes with y. So when they say, what's the domain? What can x be? It's not what is the x value, really. It's what can x be? If they give you an equation 99 times out of 100, if you're given an equation, the domain is all real numbers. In other words, I can input anything I want into it. The range will differ because it's going to be a parabolic shape. It's going to have a minimum or a maximum. But if you're given an equation and they say, what's the domain? It's put down all real numbers. You can't go wrong with them. You can, but in most cases, for Algebra 1, you can't go wrong with that. Okay, range, however, you have to look at it. Put it in the calculator, because sometimes it's hard to tell just by looking at the equation. Put it in the calculator. So if they say, what is the range and domain and range, and it looks something like this, okay, with the domain, the x, what can x be? I can put in negative 1,000,000 if I wanted, or positive 1,000,000. And this red curve is just going to continue up and to the left or up and to the right. So the domain is all real numbers in this case. The range, however, which is what can y be, this is the lowest value of y right here. And from here, it can go up to positive infinity. So if this were, say, -4, so the range would be y is greater than or equal to -4. Okay, because it can be -3, -2, -1. It can't be -5 or -4.1. It's got to be greater than -4. Okay, so for ranges, typically there's a limit on it. And depending on which way the parabola is going, it's going to be a maximum or a minimum. You kind of have to figure that out by looking at the curve or by putting the equation in there and looking at it. It's hard to figure out the range just by looking at the equation. Domain, if you're given an equation, it's all real numbers. Okay, the only time when that probably isn't going to be like that is if they actually give you a partial parabola. Okay, change colors here. So if they give you something like this, and it comes down like this, and it goes up, remember the open circle means it can't equal that number. The closed circle means it can equal that number. So if I just put some values here. Okay, so 1, 2, 3, this is -5 on the x-axis, and this is +4 on the y-axis. So if I ask the domain, what can x be? It can be anything between there and there, but it can't actually equal -5. So the domain, you say, is -5 is less than x. Remember, domain is x, which is less than or equal to 4. Because it can equal, okay, it can be equal to +4 because it has a closed circle. But it can't be equal to -5 because it has an open circle. Okay. Now here's where range gets tricky because a lot of students will go, oh, it goes from here, from this part, up to this part here. No. What is the minimum value of y? It's actually down here. Be careful on problems like this. They'll trap you. They'll put these other values in there because they know students will fall for it. Okay. Domain, that works. For range, actually, I have to go to the minimum. So 1, 2, 3, 4, 5. So -6 is less than or equal to y, which is less than or equal to whichever the higher of this one and that one. We know it's this one here. Less than or equal to, just say that's +8. Okay. That's how you do that kind of domain and range problem. Be careful. Just pay attention to what you're doing, and they are not hard. Okay. I suggest watching this video not only when you do it, but when you before you take the test, watch it again because some of the stuff will sink in. And when you actually take the test, you'll be ready. Okay. So that's that. Now, the last thing is converting vertex form to standard form. So you might get a problem that gives you something like this. Given this quadratic in vertex form, what is it equivalent to? And they'll give you 4 answers in standard form. Okay, it's easy. Now, you can do it the long way, which is actually using the calculator. You can put this in the calculator exactly the way it's written, and then put each of the 4 answers in the calculator. Whichever one lies on top of it is the right answer. Yes, you can do that, but you have to go through all 4 choices to see which one's the right answer. If you feel like doing a little bit of math, then just remember that this particular middle part here, x minus 2 squared, is the same as x minus 2 times x minus 2. And then you multiply that out. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. But remember, you have this 3 out front, so you have to multiply this entire thing by 3. And then you have this 6 on the end, and then add 6 at the end. Okay, so it's 3 times x squared is 3x squared. This minus 2x and minus 2x, you can combine them. It's minus 4x times 3, minus 12x. And then 3 times 4 is 12 plus 6. And then you can combine these like terms. And let me make some room up here. Okay, then you end up with 3x squared minus 12x plus 12 plus 6 plus 18. And that would be the equivalent term to that original expression that I gave. It's the way to do it mathematically. Like I said, you can put that in your calculator in vertex form, just the way it's written, and it'll give you a parabola, and then take each of the answer choices and put them in the calculator also, and whichever one lies on top of the original one is the answer, but it's got to lie exactly on top of it. Okay? And that's, in essence, what your test is covering. So I hope this review was good. If you have any questions, let me know or ask Ms. Stevens. Chances are you'll see her again before you take the test. And good luck.